Go. Right, today I would like to do an experiment on infrared radiation or heat radiation, and to do that I'm going to look at the different colours of these thermometers and see which one absorbs the most radiation. So firstly I've got a white thermometer and a silver thermometer and a black thermometer, and I'm going to heat them up using a light bulb. And when I heat them up with a light bulb, what I want to do is see which ones of those go up most. So I don't know if we can see the temperature now, but according to this, the temperature now is about 21, about 16, and about 20. So not all perfect temperatures. Not. I would expect them to all be the same, but they're not. So we would write down those temperatures. Now I'm going to heat them up with this light bulb. I'm just going to blast them with a light bulb and see which one heats up the most. But if I look at these thermometers, I can see that actually they're not all the same distance. So I'm just going to move this one forward. So we need to control for variables, make sure everything stays the same, except for the one thing we're looking at, which is the colour. And I'm going to move this one out again. I'm going to move this one out, just like so. They should be all pretty much the same distance away. Now, I guess we just blast it and we see what happens. Start blasting. Now I'm going to time 5 minutes. Let's time 5 minutes, and ready, steady, go. Right, 5 minutes have passed. Let's go and have a closer look in here. Now, firstly, we can see the black one. If we follow it up, we can see that is now at about 35 degrees. So that's gone up about 15. It was 20-ish and now it's 35-ish. This next one here is the silver. Now that has gone from, I think it was 16. Now it's only gone up about 4 degrees. It's gone from 16-ish to 20-ish. Hardly changed. And the white one, again, that's barely changed as well. I would say that's about 2 or 3 degrees. Now that tells us that without doubt, the one that absorbs the most heat energy is the black one. The silver and white hardly go at all. Now what I would like to have done, what I should have done, is get a fourth one with no thermometer at all. Sorry, a thermometer, but no colouring, no wrapping. And that's what we call a control. If you have a control thermometer, it's just a totally pointless one, except there is a point, because you can use it for comparison. But from this we can clearly see that black absorbs the most heat energy. Right, we've just looked at which colour is the best for absorbing, and now I'd like to see which is the best for getting rid of the heat, which is the one that loses the heat the most quickly, which is called emitting. Let's have a look. It's a similar idea. We've got a beaker with silver foil, one with black foil, and I've remembered a control this time. This one has got no foil at all. So what we're going to do is we're just going to put some boiling water into all three, and we're going to leave it for 10 minutes, and then we're going to see which is the coolest and which is the hottest. So firstly, in goes the water. I'm just filling it up to the 20 mark. Inside I can see it, you can't see it, but inside there's a 20 mark. And this one's going up to 20 as well, because they're not all 20, it's not a fair test. And then the last one, we're going up to 20 again. Now, if I put the thermometers in, these three thermometers, they're all the same. Pop them in. Pop it in. Pop it in. And now I'm going to give it just a minute, just so that the thermometers can absorb the temperature and absorb the heat energy. And so we get to look. Okay, so they've been in for 30 seconds and the thermometers have warmed up. Now I make it, this one has got a temperature of about 77 in the silver, and they've got about, I'd say 76 in the black. And then we have got, I think that's 72 in the control. But now we need to leave them, and we need to leave them for, we'll leave them 10 minutes, and then we'll see what the temperatures are. Okay, well, let's have a look at the results. Now, firstly, here's the control. How much has that gone down by? Now, that's gone, it was roughly 70, wasn't it? And now it's down to 50. So it's lost 20 degrees. It's been about 10 minutes. Now, if we look at the black one, whoa, look how much that has lost. Just by being surrounded by blackness, it's emitted lots more energy, and therefore it's cooled down much more, and that is sort of 35-ish. Lost a lot more energy. And this one here, the silver, yes, this has not lost very much at all. It's down to 60. So it's only lost about 10 degrees. It's emitted much, much less energy. Now I find that weird. I find a weird thing that black absorbs heat most, but it also emits it the most. I would have thought that if it absorbs most, it would have kept it inside it and likes the heat. But no, it absorbs heat more, but it also emits heat more. Okay?